Hello everyone, welcome to the Network Refresher section of the Offensive Security Engineering course. This is not designed to be a Networks 101. Keep in mind this is an intermediate level course. So if you're not already familiar with computer networks, this may be a bit taxing as we get past the initial content. Now, we are going to start with the OSI model, but this is just going to bring us back to center and focus on what aspects of the OSI model that we're going to be interfacing with the most in this course. So the OSI model consists of the following 7 layers. You have the physical layer, the data link layer, the network layer, the transport layer, session layer, presentation layer, and application layer. There's lots of fun mnemonics and other things that you can do to keep this memorized, but we're not really focusing on that. I'm a big fan of Googling it anyway. But for the most part, what I want us to focus on here is the fact that we'll be dealing with the application, presentation, and session layers the most when we're thinking about the network communications. And we won't harp on these too much. They're not so important that we need to focus on them, but I do want you to realize and kind of focus in on where we're kind of playing around with when you think about computer networks. We'll also be inherently configuring aspects of the transport and network layers as well, but they're not going to be as obvious. Now, the application, presentation, and session layers all have to deal with data. At the application level, we care about things like how our browser interacts with and uses data. At the presentation layer, we care about things like how data is represented and if it's encrypted or not. At the session layer, we care about the inter-host communication of the data. Think socket connections, just a step lower than the defined protocols that may exist at the presentation or application layers. The transport and network layers are mostly to deal with things like connection reliability around establishing communications, or the actual IPs of where communications are going. I'll end this brief overview of the OSI model here. Hopefully you all have your memories jogged a little. If not, please definitely research the OSI model more. I always find it ridiculous to have to memorize it, but understanding each layer when you see it is no doubt extremely important. If you memorize anything, memorize what each layer is for. Now, we won't be covering standard protocols like TCP, UDP, ICMP, DNS, etc. There's an expectation for this course that you're familiar with those to some extent. And outside of understanding them mentally, going over them isn't very practical for this course anyway. Instead, I want to talk about application architecture. In a full stack application, there are many components that drive various network communications, but I'm going to break it down into 3 small little pieces just to keep it simple. So first, you have the application web server itself. This is going to host the application, is what the end user is ultimately supposed to interface with. You also have a database that the web server connects to. This is where the application stores any relevant data you need for its processes. And then you have your end user that's going to connect to the application. This should be obvious, but it's actually very critical in defining the network architecture because it directly impacts what you let in the network. In this simple architecture that we're seeing right in front of us, that user connects to the web server and the web server connects to the database. The only necessary flow is from the user. Never does the user receive data, technically speaking. And I know your immediate thought is, well, what about when they get data back from the application? And I'll explain why that flow is still technically going from the user, not to them. You see, when a user makes a request to an application, that request gets processed. That's the first flow. We go from user to the app. The second flow is that the app needs to store some data or retrieve it from the database. One example is that the app may be trying to retrieve a name for the user from its database. Now, once that name is retrieved from the database, the app is going to process it and then display it on the page. Now the user can see it, and the data has been retrieved and processed, but the connection flow is only technically one way. No one ever needed to poke a hole out of it. You see, the user connected the web server to initiate the request, but then the user also connected the web server again to get the data. The web server never talked back to the user. Speaking of which, do you see a fatal flaw in our network diagram right now? Yeah, there's no firewall at all. Right now, the user can both fully access our web server and our database too. So with our current network, anyone may be able to initiate any communication that they want. So let's add a firewall in, and some kind of internal network security groups while we're at it. So we're going to restrict this to port 443. That's going to be external only on the firewall, and then route into our web server. And then we're going to add some network security groups internally that only allow one way to 3306. That's going to be our MySQL port from our web server to our database. Awesome. So now that our firewall is added in, we can actually look at setting up some new stuff. We're going to expound on this. Let's set up Active Directory. That's pretty common. So I'm going to keep this simple and just add in a single domain controller and a single domain system to our diagram. So of course we need some segmentation and network rules to keep things running smoothly here, but Active Directory has a lot of requirements, as you can see. I'm not going to step through them all, but I'm going to have them listed here. And this is kind of what usually needs to be allowed when you're configuring domain environments. Of course, you can restrict these different tiers or based on what kind of feature functionality you want. Maybe you don't want RDP everywhere. It's totally up to you. All right, cool. So now we've got a little bit of a more complex network going on. And we're going to wrap things up real quick by talking about VPNs. Now, the context of this course does assume that you're familiar with VPNs already, but just in case you're a little rusty, let me give you a quick overview. VPN stands for Virtual Private Network, and it's a really useful technology that allows us to access networks that we aren't physically located at. Essentially, this creates a network on the server itself that we can somewhat expose to the world, and then this will open a port that we can authenticate to, and once authenticated, we'll be both tunneled through it and given access to the network therein. From there, it's up to both the server's local firewall and any applicable network security groups to determine where we can and cannot go. Like with our Active Directory environment here, it's closed off from the world. But with the VPN and some tweaking of network configurations, we could access it in a relatively secure manner from anywhere. So let's see what that looks like. So let's add our VPN server to our diagram here, and now we should be able to VPN into the environment and even RDP into our main controller with relative ease. The point of this exercise is just to build out a network topology from scratch, get a refresher on all the different technologies that are usually in a network at a small scale. So hopefully you can see this, kind of see something familiar if you've ever worked in system administration before, or maybe if you're a pen tester, kind of small scale what you may see in a given environment. You got a web server, a database, and some domain controller stuff for Active Directory, and a VPN. And then exposed on the firewall, you have some kind of external points for the web server and for the VPN itself. So hopefully this little walkthrough exercise has accomplished that goal in a network refresher and lets you see how all these pieces kind of traditionally fit together. That's it for this lecture. We'll see you in the next one.